Comptia Networks Plus course. Service Set Identifiers, Word Equivalent Privacy and Media Access Control Address Authentication. What the original designers of 802.11 did to create basic security was to include the use of SSIDs, open or shared key authentication, static WEP, and optional media access control, MAC authentication, MAC filtering. Sounds like a lot, but a lot of these really offer any type of serious security solution. All they may be close to adequate for use on a common home network, but we'll go over them anyway. An SSID, a common network name for the devices in a wireless LAN system that create a wireless LAN. An SSID prevents access by any client device that doesn't have the SSID. The thing is, by default, an access point broadcasts its SSID in its beacon many times a second, and even if SSID broadcasting is turned off, a bad guy can discover the SSID by monitoring the network and just waiting for a client response to the access point. Why? Because, believe it or not, that information as regulated in the 802.11 specifications must be sent in the clear. How secure? Supplying the correct SSID, but it's the most common method in use today. With shared key authentication, the access point sends the client device a challenge text packet that the client must then encrypt with the correct WEP key and return to the access point. Without the correct key, authentication will fail and the client won't be allowed to associate with the access point. But shared key authentication is still not considered secure, because all an intruder has to do to get around this is detect both the clear text challenge and the same challenge encrypted with WEP key and the cipher the WEP key. Surprised shared key isn't used in today's wireless LAN because of clear text challenge. With open authentication, even if a client can complete authentication and associate with an access point, the use of WEP prevents the client from sending and receiving data from the access point unless the client has the correct WEP key. A WEP key is comprised of either 40 or 128 bits, and its basic form. It's usually statically defined by the network administrator on the access point and all clients that communicate with that access point. When static WEP keys are used, a network administrator must perform a time-consuming task of entering the same keys on every device on the wireless LAN. Obviously, we now have fixes for this because tackling this would be administratively impossible today's huge corporate wireless networks. Last, client MAC addresses can be statically typed into each access point, allowing MAC filtering and any frames to show up to the AP without a known MAC address in the filter table will be denied access. Sounds good, but of course all MAC layer information must be sent in the clear. Anyone equipped with a free wireless sniffer can just read the client packets sent to the access point and spoof their MAC address. If you have a small number of wireless clients, you don't want to deploy an encrypted based access model. MAC address filters may be sufficient. Geofencing. Geofencing is the process of defining the area in which an operation can be performed by using global positioning, GPS or radio frequency identification to define a geographic boundary. An example of usage involves a location aware device of a location based service LBS user entering or exiting a geofence This activity could trigger an alert to the device's user as well as messaging to the geofence operator. Remote authentication dial-in user service 802.1x. Remote authentication dial-in user service Radius is a networking protocol that offers us several security benefits: authorization, centralized access, and accounting supervision regarding the users and or computers that connect to and access our network services. Once Radius has authenticated the user, it allows us to specify the type of rights a user or workstation has, plus control what it or they can do within the network. It also creates a record of all access attempts and actions. The provision of authentication, authorization and accounting is called AAA, which is pronounced just like the automobile insurance company AAA. It's part of the IEEE 802.1x security standard. Radius has risen to stardom because of its AAA feature and is often employed by ISPs, web servers, wireless networks and APs, as well as network ports, basically by anybody who wants or needs a AAA server. And these servers are only becoming more critically important in large corporate environments, and that's because they offer security for wireless networks. From the Linksys security screen shown earlier, you can see that Radius is an available option. If you choose it, you'll be asked for the IP address of a Radius server so the AP can send authentication packets. Figure 1221 shows how the AP becomes the authenticator when you choose the Radius authentication method. Now packets must pass through the AP until the user or the host gets authenticated by the Radius server. Temporal key integrity protocol. Put up a fence and it's only a matter of time. Put up a fence and it's only a matter of time until bad guys find a way over, around or through it. And true to form, they indeed found ways to get through WEP's defences, leaving our Wi-Fi networks vulnerable, stripped of their data link layer security. So someone had just come to the rescue. In this case it happened to be the IEEE 802.11 task group and the Wi-Fi Alliance joining forces for the cause. They came up with a solution called Temporal Key Integrity Protocol, TKIP. The Wi-Fi Alliance unveiled it back in late 2002 and introduced it as a Wi-Fi Protected Access, WPA. The little beauty even showed us lots of money because TKIP, just like TKIP, didn't make us upgrade all our legacy hardware equipment in order to use it. Then in the summer of 2004, the IEEE put its seal of approval on the final version and added even more defensive muscle with goodies like 802.1x and AES-CCNP, Advanced Encryption Counter Mode, CBC MAC protocol, upon publishing IEEE 802.11i 2004. The Wi-Fi Alliance responded positively by embracing the now complete specification and dubbing it WPA2 for marketing purposes. A big reason that TKIP doesn't require buying new hardware to run is that it really just kind of wraps around the pre-existing WEP encryption key, which was way too short, and upgrades it a whole lot to much more impenetrable 128-bit encryption. Another reason for TKIP's innate compatibility is that both its encryption mechanism and the RC4 algorithm used to power and define WEP respectively remained the same. but there are still significant differences that help make it seriously tough shield. It is one of them being that it actually changes each key's packet key. Let me explain. Packet keys are made up of three things: a base key, the transmitting device's MAC address, and the packet's serial number. It's an elegant design because although it doesn't place a ton of stress on workstations and APs, it serves up some truly formidable cryptographic force. Here's how it works. Remember the packet serial number part of the transmission key. Well, it's not just your average serial number, it's special. TKIP governed transmission ensures that each packet gets its very own 48-bit serial number, which is augmented with a sequence number whenever the new packet gets sent out. Not only serves as part of the key but also acts as the initialization vector. And the good news doesn't end there, because each packet is now uniquely identified. The collision attacks that used to happen using WEP are also history. Plus the fact that part of the packet's serial number is also the initialization vector prevents something called replay attacks. It takes an ice age for a 48-bit value to repeat, so replaying packets from some past wireless connection isn't just going to happen. Those recycled packets won't be in sequence, but they will be identified, thus preventing the attack. Now for what may be truly the coolest thing about TKIP keys, the base key, because each base key that TKIP creates is unique. No one can recycle a commonly known key over and over to gain access to a formerly vulnerable WEP wireless LAN. This is because TKIP throws the base key into the mix whenever it assembles each packet a unique key, meaning that even if a device has connected to a particular access point a bunch of times, it won't be permitted access again unless it has a completely new key granting it permission. Even the base key itself is a fusion of something called nonsense, an assortment of random numbers gleaned from the workstation, the access point, and each of these devices' MAC addresses. So this should also be referred to as a session secret. So basically, if you've got the IEEE 802.1x authentication working for you, rest assured that a session secret absolutely will be transmitted securely to each machine every time it initiates a connection to the wireless LAN by the authentication server, unless you're using pre-shared keys. That is because if you happen to be using them, that important session secret always remains the same. Using TKIP with pre-shared keys is kind of like closing an automatically locking security door but not enabling the security settings and alarm. Anyone who knows where the secret latch is can get in right there. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.